the top trends in HVAC system design that make clean rooms more energy efficient?
So I think there's a few trends, but the top trend is probably to do a performance-based strategy where you measure particles in specific spaces within the room or over a representative grid in the room, and then you can reduce the amount of airflow or air changes based on that performance requirement. So as long as there's a space within the suite that doesn't require more air, you can reduce that airflow. And if there's areas that actually require a little more airflow, you can adjust that over time.
How does this trend apply to clean rooms in the pharma industry?
So various types of clean rooms. And when we say types of clean rooms, we talk about industries from pharma to microelectronics to aerospace. And in pharma, in the EU standard and the FDA standard, they actually allow for a performance-based solution that defines air velocity and particle count, not specifically air change rates. Most of the industry assumes that air change rates define the other two, but the reality is now that there are better and more reliable particle counters, you're able to increase your performance in the EU and FDA standard. Um, and it takes a little bit more design time and a little more operational calibration of particle counters, but it's a very nice way to save energy and get more efficient in those markets.
What about clean rooms in other industries?
In the case of things like microelectronics and aerospace and other industries, food science, the main point there is a lot of the standards are driven by not always particle counts, but a lot of times by air changes. And that's where there's even a bigger opportunity because we can work with the regulators to try and define better zone by zone requirements for specific particle counts based on particle counters permanently monitored in space.
How do these HVAC strategies actually work to make clean rooms more efficient and reduce energy use?
So specifically to HVAC, you're going to have either variable volume control devices, meaning you'll have an ECM motor, an electrically controlled motor, or you'll have a VFD, and all of those types of devices that allow you to modulate the airflow from a maximum to a minimum within a range, give you the ability to actually change the velocity of the airflow from top to bottom or left to right. And in doing that, again, changing the actual total air change in the space. So it saves energy by reducing the amount of horsepower you need, which is a result of reducing the amount of air changes uh, to meet the specific need in a specific zone for a specific number of particles per square foot.